So in our final video for this chapter, we're going to do a practice problem where we need to find the empirical and the molecular formula for a compound given mass percents and it's the compound's molar mass. First thing I want to say is you see a star here, and usually I use stars to bring your attention to PowerPoints that are particularly important because there will be questions like them on quizzes or exams. There will be a question like this on your Unit 2 exam, not on your quiz because you've only got 10 minutes for your quiz, but there will be a question like this on your Unit 2 exam. So let's go ahead and dive right in. So I have some mass percents given. I give you the molar mass of the compound, and I ask what the molecular formula for the compound is. So I didn't say anything about the empirical formula, but the only way that you can calculate the molecular formula for a compound given this information is to first find the empirical formula. So that's always the first step when finding a molecular formula when given mass percent data and a molar mass. Find the empirical formula first. So we're going to go through the 3 steps that we've talked about in the previous videos to find empirical formula. First being we need to assume a 100-gram sample, so our mass percents automatically become grams. You can just chop off the percent sign and put grams. Convert those grams, that mass, to moles using the molar mass for each element. It's on your periodic table. Again, written appropriately as a conversion factor so you can see your units cancel. And then doing that division gives you these number of moles. So second step, convert your mass to moles. Then our third step is we need to get those numbers into whole numbers to use as subscripts in our empirical formula. And to do that, you look at the numbers that you have, which in this case is 1.67, 2.18, 2.19, and you divide each of them by the smallest number. 1.67 is the smallest, so I divide each of them by 167 to find the simplest whole number ratio. Doing that for the elements, for carbon that becomes a big fat 1. For hydrogen and for chlorine, we get 1.31. And so now here's where I was talking about the times when you cannot round numbers when using them as subscripts for your empirical formula. So that 1.31 is it's too far off from a whole number to just round. So how are we going to get this 1.31 into a whole number? Well, that point, that's approximately a third. So if we multiply those 2 numbers along with this subscript for carbon by 3 to clear the fractions, then when we do that, we get a nice whole number for carbon. These subscripts for hydrogen and chlorine are now close enough that we can round them to 4. So our empirical formula for this molecule is C3H4Cl4. Now in the last slide for this little video, I'm going to talk about when you can't round. There's going to be 2 instances where you can't. This 1.31 is an instance where it's just too far off from a whole number to round, and so we needed to multiply by the appropriate fraction to get them to be whole numbers. And when you do that, please note that since we multiplied the H and the Cl by 3, we had to multiply the carbon by 3 as well, even though it was already a whole number. Just think about the reason why we do that in the following way. If you add 2 to one side of an equation, you have to add 2 to the other side of the equation, which you multiply one subscript number by to get it to be a whole number. You got to do it to all of them. Okay. So from this first slide, we have done our 3 steps to find the empirical formula, and we have found it as C3H4Cl4. So we're halfway there in solving this problem, which is asking for the molecular formula of the compound. We now have the empirical formula. And we should use that empirical formula to find the mass of that empirical formula. And again, we can do that using our periodic table and the subscripts from the balanced formula. Once we have that empirical mass, we can look at our given molar mass, which is 545, do the appropriate division, which is molar mass, given molar mass divided by the empirical mass, and that essentially gives us the whole number 3. You should always get whole numbers when doing this division. So that means we have to use this 3 and multiply it by the subscripts in our empirical formula. So doing that gives us a molecular formula in our final answer of C9H12Cl12. So if you can do a problem like this, and there's other examples on the Canvas worksheets that I've posted, if you can do a problem like this, you should have no trouble with problems on the Unit 2 exam, because you're able to do mole calculations, you're able to do mass, take care of mass percents. Okay? And like I said, a problem like this would not be a good quiz question, but there will be one like it on the Unit 2 exam. And so I said, well, when do you round values in the empirical formula? Like with the previous example, when we had a number that was 0.33. If you get a number like that, you need to multiply by 3 to get the appropriate subscripts. And the other example that you may come across when doing empirical formulas is if you get values that are 0.5, then you would multiply by 2 to get whole numbers. Now, there are other examples of when you need to multiply by a factor to get whole numbers for empirical formulas, but these are the 2 examples that I think that are most prevalent, that you'll come across most in Intro Chem. So I wanted to bring those to your attention.